Hello everyone. So welcome to another video on my YouTube channel, and this is a new playlist, and I'm starting this new playlist on the topic called about decision making that is used in management. So this is actually a process or chapter from operations research in management studies. So and specifically the topic that we'll be looking for is called as AHP, that is analytic hierarchical processing. Okay, so I'll show you the sample question that will be usually studied in this AHP. So if I just switch over to my document, so here you can see there is a question like this. Okay? So in this question, some kind of data is given, and it is asked to select a best suitable apartment. So if you look at this apartment, we can see here, right? So there is a three types of apartments, that is terraces, vistas, and Foxfield. Different three types of apartments are compared with again the same terraces, vistas, and so it's a pairwise comparison between each with respect to the criteria cost, then condition, then location. Yeah, so in other words, if you see, if you compare terraces with terraces, obviously it's the same thing, so no comparison. So it is just one. Whereas if you compare terraces with vista, the cost, so it is two. That means the vista is more costly compared to terrace, or vice versa, whatever, we'll come to it later. So it is just something like that. So in this way this kind of data is given, and finally you are asked to choose the apartment, whether best apartment is terrace, best apartment is vista, or best apartment is Foxfield. Anyway, so before we jump into this question, you may just pause this and read this question. Before we jump into solving this question, I would like to cover some theory. What is this AHP and how to solve it? Okay, so let us cover that theory now. So I'm going back. So here you can see this is the analytical hierarchical process, AHP. Okay, so what is the definition? So it is simply, or why this AHP analysis is used is ranking and selecting the best alternative based on multiple criteria. So whenever you have a problem like this, selecting the best alternative based on multiple criteria, then you can apply this AHP process. Okay, so this is a kind of a mathematical tool. A lot of manipulation, mathematical manipulations are there in this, but it's a mathematical tool to identify. Okay, so again, the keywords are alternatives, criteria. So remember these three keywords. So, what are the alternatives you are having, and what is the criteria you will use to evaluate those alternates, and finally come to decision. In fact, you will be ranking the alternatives and selecting the best in that. Maybe examples will help you understand. Okay, so rank and select the best dash based on dash dash and dash. So this is the alternative, and these are the criteria. So, for example, let me get my pen. So, what is the okay? The first example I can take is something like the question that I just sometime showed. So, apartment. So, I'm just saying best apartment. That means there are multiple apartments. Okay, so apartment A, B, C, D, whatever. There may be five apartments, and you want to rank them. Which is the fifth best, fourth best, third best, second, and which is the best. So, ranking and selecting the best apartment based on what? So, usually the criteria will be cost, and the criteria may be the condition in which it is there, and then maybe the location. So whether is it nearby to the market, or nearby to the train station or whatever. So location parameters, then the condition, whether it is new building or old building or whatever, and so on, and what is the cost. So obviously now you may feel that, look, some people may say, I don't care, how much it costs. I want the best location. So they have more the criteria. There are three criteria, right? But location criteria may be more important for some person. It has to be near to my office, it has to be at this location, it has to be near to a shopping mall, whatever. I don't care what is the cost, I don't care what is the condition. So, but whereas some other person may have more importance to cost, they say no, no, the cost should be less. Okay, even if it is in the outskirts of the city, it is very far and I have to travel. Okay, I will manage, but I want a quiet and less cost place, and that is why. So even the criteria may be same, but the importance of the criteria depends on person to person. So when you are doing this AHP analysis, there is something called you have to interview the client. Okay, so according to you, is cost more important or location more important? Okay, let's say the person says cost more. How much more? So is it that you give like it's a 1 to 10? So 1 means both are equal, cost and location are equal. Now I'm comparing cost and location. Whether 2 means yes, cost is little bit important, but location is not that important. uh, and then if the value is more 3, 4, 5, then the more increased value you give, that means that criteria becomes more important for you. Otherwise, if the value is 1, then you have the same important. Anyway, so too much we are discussing. Let's take one more example. Ranking, rank and select the best dash based on S. So maybe best investment fund. Let's say you're an investor, and there is a different projects are there. You have 5 different projects or 7 different projects in fund where you have to put your fund. Now by investing your fund, you may gain a profit or you may gain a loss, so you don't know. So according to that you need to, but according to certain data you need to select the best investment fund. So in this case, so maybe first thing is you will see what is the rate of return. So your more important criteria, you need high returns, but then risk is also there. So usually for this kind of things where risk is more, returns are also more, and if risk is less, the returns are less. But you want to balance them out and select the best one, and then maybe something like whatever is the reputation. So a certain company, maybe the reviews. So whoever is providing you the investment fund, what is their past record? What is their past performance? Based on that, you can also select. Okay, so this is one more example. Okay. So example 3, rank and select the best. You can also pause the video, think about, at least you should come up with 2 or 3 examples. Then we can say, okay, maybe you got the idea of what is this AHP, what is the alternative means, what is the criteria means. Anyway, so example number 3. Let me come up with some kind of example number 3. Let's say you want to purchase a car. Okay, so the car model, so which car you want to purchase. So there are so many varieties of cars all over the world. So which car you want to purchase? While you are purchasing car, what you will see? Okay, so maybe for what are the things is, uh, let's say appearance, and let's say mileage, and let's say the price, of course, and let's say some other something like the comfort level. Okay, so and maybe the safety. Okay, so I'm giving more criteria. So the number of criteria need not be always 3 criteria. The criteria may be 4, 5, whatever more criteria. Okay, so you give more importance to appearance or you give more importance to safety. So there are some people, they say okay, it has to be safe. I want in case of accident I should not get hurt or something like that. I don't care what kind of appearance it has. Some people may give more importance to mileage. Some people may give more importance to comfort. It has to be comfort. I should be able to sleep in my car, whatever. So all these criteria are there. So given all these criteria, and given let's say there are 10 models in the market, out of the 10 car models, which is the first best, second best, third best, fourth, you want to give the ranking, then you can do this. So finally, one more example. Let's do in the interest of time. Let me adjust my camera a little bit. Yeah. So rank. It's not rand. It's rank. Okay. So rank and select the best dash based on whatever. So Again, you can think of one example. So anyway, since it's the last one in this page, I'll go with one fun example. So let's say you are interviewing, and you are interviewing for a office secretary. Okay, so you have multiple secretaries, maybe 10 secretaries have applied, and you have to do the interview. And how will you select which is the best secretary, which is the second best, which is the third best, and so on? How will you select? What is your criteria? So some people may take, the criteria may be dressing, and one other criteria may be, the smile. Another criteria may be, let's say, the walk. Okay, so how does the secretary walk? And so all these things, you can have, the beauty, you can have all the other whatever criteria, colorful criteria that you want to find. And maybe, of course, the most important is the skills. Okay, so whether the particular secretary that you want to select, can they perform the analytical hierarchical process, problem solving, or can they do linear programming, or can they do, can they operate excel, that could be one criteria. The skills could be one criteria more important for a particular interviewer, whereas some other interviewer may completely go by, the dressing style, and the smile and walk, and all, not worry about the skills and so on. It depends on the interviewer also. The ranking will change. So anyway, so overall, what I'm trying to come out is that this analytical hierarchical process is a mathematical process which can be applied in a situation where you want to choose a best alternative among the multiple criteria. And I have given these examples. Okay. So, but then anyway, our problem is still there. So we will come back to that problem. Uh, some more theory is there. Okay, here we got the understanding of what is this analytical hierarchical processing. Now, how to do the analytical hierarchical processing? Here is where it is very important. So this is the summary of analytical hierarchy process. If you understand this diagram, then that's it. You have cracked the AHP process. Okay. So what is this diagram? Okay. So again, I don't know whether such a diagram exists somewhere in the internet, but I have read, about this from one of the textbooks, and from my understanding, I created this, diagram as per my understanding. How to do this. So it may not be there in any standard textbooks. You may be finding it only here on this particular YouTube video. So, but anyway, so let's see. See, the AHP process. It's a process, right? Process has three things. Process one, or we can say sub process. In order to complete this analytical hierarchical process, you need three sub processes. Okay. The first one is to create what is called as a criteria preference matrix. Create or calculate. So using the input data, you have to calculate this particular, do some mathematical manipulations, and calculate the CPM, criteria preference matrix. Then you have to calculate the ranking of criteria, or let's call it RC. This is my terminology. So once you do this sub process 1 and 2, or let's call them as 1 and 2, then the whatever this matrix, and here this will be like a vector or a single column matrix. Now we need to do the matrix multiplication of these two. So you have to multiply CPM, and on the right side you have RC, and left side is this one. You have to multiply them. Then you will get the best, not only the best alternative, you will get all the alternatives with their ranking. Yes, the score will be there. If the score is more, then it is best. It is ranking will be high, or ranking will be better in that sense. Okay, so that is the this thing. So if you do 1 and 2, then finally you got the best alternative. Then what is the purpose of 3? So purpose of process 3 is the consistency index. Okay, so here what happens, because this AHP process is dependent on the surveys. So we have to survey the people, right? So again, for example, if you take this last case, how do you select a secretary? So there are, CEO will give a different criteria, or different weightage to this criteria, and HR may give a different criteria, and the project team lead may give a different criteria, and so on. So different people, some people, as I was saying, give more importance to skill, and some people give more importance to dressing, smile, or walking, or whatever. So the same with all other examples also. So whatever is the analysis, your it has to be consistent. So to check the consistency of that choices, so there is this consistency index you need to calculate, and the consistency index will tell you, is the result that we obtained here, is it valid, yes or no. If the AHP result, based on this CI, you can conclude, if it is valid, then yes, you can consider this as a good thing. And if it is invalid, or no, then okay, you got some result, but that result is simply, you can just throw it in the dustbin. It is not the proper calculation, because your input data consistency index itself is not consistent, or your uh, the input data itself is not consistent. So now people will say, okay, why should I spend half an hour doing the step 1 and step 2, and then finally come to step 3, again spend more 10 minutes, calculate the finally here, if it comes no, then my initial half an hour wasted, right? So yes, that is also correct, because these are all sub processes. Instead of doing 1 and 2 first, directly go to 3, and then make it, if it is saying valid is yes, then you can try 1 and 2, and then you can say, otherwise you can say, if it is saying no, then you don't even have to touch this 1 and 2 process. You can directly say, the given data is not correct, and I will not do any unnecessarily, I will not waste my time, kind of thing. But there is one small problem. The problem is this RC value, whatever is there, that is utilized in the CI. So without this RC value, you cannot calculate the consistency index. So therefore, okay, forget about the one. At least two you have to do. After process two is completed, then you can go to process three. And here, if it says yes, then you come to process one. Okay, so I hope this diagram you understood. By the way, what we have to, how to do this, how to do this, how to do, still it's not explained. But what I want to explain is the overall big picture of analytical hierarchical process. So again, to summarize, analytical hierarchy is a process. In that process, there are three sub processes. Process one is to find the criteria preference matrix, and two is to find ranking of criteria. And if you multiply this with this, then we get the ranking of alternatives. So which alternative is the top, which alternative is second best, third best, so on. In that order, it will come. But whether this result is correct or not, valid or invalid, you need to do this third process. But in this third process, this RC also required. So based on this RC, you can generate, you can identify whether it is valid result or not. Based on that, you can give the final advice to the client. Okay, so this is about analytical hierarchy process. Okay. Now the video is still not over. Okay, so if you are feeling already sleepy now, please stop your sleep and continue listening to me. The video is still not over, and what I have to still now pending is talk about this criteria preference matrix and ranking, how to do these three steps. Okay, so first step, second step, third step, I will explain next. Okay. Now the best way to explain is to use the example problem, but right now I will only explain using the what you call steps, and in the next video I will actually solve the example problem. Okay, so let's look at this criteria preference matrix. In fact, step 1 and step 2 both I have covered here in this two things, and you will see they're very much similar. So let's first focus on this step 1. Okay, uh, so since we are focusing on this one, let me just cover this thing. So now look at this one. So criteria preference matrix, how to find it? Okay, so select the criteria. What is the criteria? There is always, I said, there are multiple criteria, right? So for example, here cost, condition, and location are criteria. Here return, risk, and reputation are criteria, and here appearance, mileage, comfort, price, safety. All these are criteria. So select any one criteria. So for example, you select safety, then appearance, then mileage. All these things you have to process. Okay, so let's come back to it. Select any criteria, then get the piecewise comparison matrix of alternatives for this particular selected criteria. What is this piecewise comparison matrix? I will explain later when we are actually doing. Then calculate the totals, then normalize, then synthesize, and finally you will get a one column that you store for that one column. And then again repeat for other criteria. Like that, if there are five criteria, you have to repeat this process five times. Yes, again, right now, if you don't understand this, don't worry. I will explain it using a example problem. Now, once all the criteria is concerned, the problem may have three criteria, very good. The problem may have seven criteria, that is very bad. You have to do seven times all this calculation. Finally, your result is the CPM, that is criteria preference matrix. Okay, CPM is a criteria preference matrix, that is the final output. Now coming to the second step, so here you have to do ranking of criteria. Here we get the pairwise comparison matrix of criteria. Here there's a pairwise comparison matrix of alternatives, whereas here there's a pairwise comparison matrix of criteria. So this both are matrix comparison matrices only, but this one is for the criteria. So again, all this information will be given in the question. You have to choose properly which one you are selecting, then calculate the column total, then normalize same, then synthesize same, then directly there is no looping here, there is only one time process. Then finally you get the RC. And as I said, you get two matrices. So here CPM you are getting from here, RC you are getting from here. You have to multiply these two, you will get the ranking of alternatives, and out of all the ranking of alternatives, whichever has the highest value, that is the best alternative. Next, let's come here and talk about this process 3, consistency index. So in consistency index, again, get the pairwise comparison criteria. So you already saw this. Okay? The same thing here you are having, right? Pairwise comparison matrix of criteria. So same this one you take, and this one you should multiply with the last one. Okay, so these two, the first one and last step, so these two you have to multiply. Okay, so here that's what I'm saying here. Get the this one, multiply the above with the ranking criteria RC. So how to multiply? You have to do matrix multiplication. So basically you have taken the comparison matrix multiplied with RC. Now again divide with RC. So one time you are multiplying, one time you are dividing. But at the time of dividing, you have to do element wise division. At the time of multiplying, you have to do matrix multiplication. Okay? Again, these are mathematical things. You will learn when I show you the example problem. So first multiply by using matrix multiplication, then divide using element wise division. Then finally you will get a one vector. Then you find the average of the vector. So then you will finally get a one single number. So that is the average. Now from that you calculate the consistency index. Average minus n by n minus 1, where n is the number of criteria. Then you will get the criteria index. Now if this criteria index is less than 10% of random index, okay, so then your say AHP is valid. If the criteria index is more than 10% of random index, then no, your AHP analysis is invalid. Therefore, your results are also not reliable. Okay, so most probably this will happen. Most probably you will get a valid only, because even the people who set the questions, they don't waste their time. And but what is this RI? So depending on the number of criteria. So for example, if you have for example, take the case of this car model. How many criteria we have? One, two, three, four, five. Five criteria we are having: safety, appearance, mileage, comfort, and price. So in that case, if I go back here, for five criteria, the RI is 1.12. The 10% of this means 0.112. Therefore, your consistency index should be less than that. Then only it is valid. In fact, ideal condition, best condition, your consistency index will be zero. So if it is zero, then perfect. Your AHP analysis is exact, on point. Anyway, so this is all the process. So I think the length of the video is getting more. So let me once again show you all the pages once, so that you can take. So this is the definition. This is example 1, example 2, example 3, and next I have this is the entire process. Okay, so this you have to understand very much. I'll be referring to this while solving the example. Then we have this criteria preference matrix. Then we have ranking of criteria. Then we have consistency index calculation, and then comparison with RI, and finally determining whether your result is valid or invalid. Okay, so this is the entire AHP process. Okay. In the next video in this particular playlist, I will come back with a actual example problem, and that is what this problem we're going to solve, and then we will come to know how to go about this. In fact, if you feel like you want to right away try this, so please, you can pause the video, look at the question, and try to solve it. So again, thanks for observing this theory video. Next, we'll show the problem. So if you like this video, please press the like button, and you can subscribe to my channel. See you in the next video. Thank you.